Thanks. Well, no, but I mean, you want to be able to see. Ready? My name is Jordan Bucher. This is Christopher Burns. This is Himali, Katie, and Kevin. And what we're here to do is present our findings for a capstone project for carpet waste gasification. We did a technical, economic, and environmental assessment for the use in carpet mills. This is an interim presentation, so we haven't got to the economical analysis yet, but we wanted to use you as industrial and academic professionals to kind of as a sounding board before we take this further, to get any feedback that you can offer before we take it to the client with the final presentation and project. What we're going to be discussing today, we're going to go over the problem statement, principles of gasification, the methodology that we used for the analysis, proposed systems for gasification that we analyzed for this project, the uses that we found for SynGas, that's synthesis gas, which is a result of gasification, an environmental analysis, and finally conclusions. So the problem statement is that we have about 250 tons per day of post-consumer carpet waste. Currently, disposal fees have to be paid for this. So we would like to reclaim a portion of the chemical energy that is contained in this carpet. Post-consumer carpet has a lower heating value of around 9,000 BTUs per pound. To put that into perspective, middle grade coal has a lower heating value of around 11,000 and natural gas around 20,000. The gasification process of post-consumer carpet will produce syngas with a lower heating value of anywhere from 8,000 to 12,000 BTUs per pound. So the heating value for the syngas would be higher than that for just combusting the carpet to produce steam. The principle of gasification is just a process to convert carbonaceous materials into synthesis gas. The general equation here is that the carbonaceous material is reacted with some stoichiometric amount of oxygen to produce carbon monoxide and hydrogen, which carbon monoxide and hydrogen are the main components of synthesis gas. You can also react it with steam, which will yield methane as part of the synthesis gas.
As Jordan said, we have 250 tons of PCC available to us, and we use that as our basis. And basically what we decided to do is to split that into two separate streams. So we're going to take 125 tons per day and put it into two gasifiers. From someone who works in the carpet industry, we were able to obtain this carpet composition, basically broken down into weight percentages of the carpet that they work with every day. It contains 17% polypropylene, 35% calcium carbonate, from which 80% of that 35% is removed by some mechanical method before it enters the gasification. We have 6% polyethylene terephthalate, I can't say that, PT, 17% nylon 6, 14% nylon 6,6, and 11% styrene butadiene. And we also removed 100% of the nylon 6. We also wanted to get an idea of how much energy we could get out from this process. And basically what we did, we took the heat of combustion for each of the materials that's available in the PCC, multiplied it by the flow rate for each of the gasifiers to get a total energy output in million BTUs per hour. And what we came up with was 77 million BTUs per hour theoretical energy yield.
For our calculations, we use this Cascade modeling program. We model the gasification process through this program, which helped us to get the material balance and the energy balance. our first proposed system was the air gasification, gasifier, sorry. The air and the post-consumer carpet goes into the gasifier, and if the product comes out is the SynGas and the calcium oxide that goes to the cyclone and separates the clean synthesis gas and the calcium oxide. And the clean synthesis gas we use to get a steam to the boiler. In the air gasification gasifier, nitrogen is present that reduces the heating value, and it produces the nitrogen oxide. This is the same as the air gasifier, but only difference between the air gasifier and oxygen gasifier. We didn't put the separator over here, but to separate the oxygen from the nitrogen, we use the air separator. Everything else is basically the same as the air gasifier. Air gasifier in air gasifier, the capital increases due to nitrogen separation because we need to use the air gasifier, air separator to separate oxygen and nitrogen. Capital decreases due to the volumetric flow rate of gasifier. This is also very similar to air and oxygen gasifier, but the only thing on this one, we will get methane too with the SynGas and calcium oxide. And we also use the cyclone over here, and same thing like boiler to get a steam out of it. Steam gasifier lowers the temperature and produces the methane. It's higher heating value synthesis gas.
The synthesis gas, for each of the gasifiers, the air gasifier is going to have hydrogen and carbon monoxide as the combustible materials, with a large portion of nitrogen that comes in with the air along with it, which helps moderate the temperature, but also it dilutes the combustible gases. In the oxygen gasifier, there's not the nitrogen present because it gets separated out, and we just feed pure oxygens. So the temperature is a lot the higher temperature, but it's more condensed combustible materials. And the steam gasifier, there's also not nitrogen present, but you also have methane, which raises the heating value and makes it more suitable for use in a gas turbine. Current SynGas use, air and SynGas can be combined in a boiler to produce steam for use in a plant. Another potential use of SynGas would be air and SynGas are combusted in a boiler and to produce high pressure steam to spin a steam turbine to produce electricity. And then that the low pressure steam can be either used for plant use or condensed back down for circulated through. The most efficient use of SynGas would be air and SynGas combusted in a gas turbine to produce electricity, and then the hot exhaust, the energy from that's recovered in a boiler to produce high pressure steam for use in a steam turbine to produce more electricity.
Now, to assess the environmental performance of these gasifiers, we looked at both energy recovery and some primary pollutants. So here you see we have, for the air gasifier and also the oxygen gasifier, we have about 58, or we're approximating 58 million BTU per hour, and that's based off of the 77 million BTU per hour potential of the incoming stream. And that averages, that's about 5,800 BTU per pound of our post-consumer carpet waste. Now for the steam gasification, we approximate about 35 million BTU per hour, about 3,500 BTU per pound of post-carpet waste. And then the primary pollutants, we looked at carbon dioxide, which is a greenhouse gas and contributes to global warming. So we approximate about 14,000 pounds per hour of carbon dioxide, which is based on our basis 240 pounds of CO2 per million BTUs that we're recovering. And compared to coal, that's 13% higher carbon dioxide emissions per BTU. And we also, and that's the same for the oxygen and the air gasifiers. For the steam gasification, it was a little bit less, just 11,000 pounds per hour of carbon dioxide, and it's 48% higher emissions than coal. But then for the air gasifier, we also had to deal with nitrogen oxides. Those are negligible for the oxygen and steam gasifiers because there is very little, if any, nitrogen in them. But for the air gasification, we had about 300 pounds per hour of nitrogen oxides, which is 14% less than coal.
So in conclusion, carpet gasification is technologically and environmentally feasible. We're currently working on the economic analysis, and we understand it's going to play a major role in the overall decision to use one of these processes, and it's going to be available in our final report. And like Jordan said earlier, basically we're like design engineers and you're like our bosses. We are presenting our work to you in hopes that you can offer feedback to us before we present this product to our customer. So with that being said, what were the strong points? What can be improved upon? What can we leave out? The floor is open. Any questions? Any suggestions?